In today's session, I want to focus on another really important algorithm that's frequently used and which I use in my research all of the time. And that is matching data to other data. As an illustration here on the first slide, consider that you have a list of animals and somebody else has given you a second list of animals, but they're in different orders. And the goal is to find a way to tie the animals together, to match them. A fairly simple concept, I think. Yesterday, we spent a lot of time discussing databases. Perhaps the most important thing to come out of that discussion is the concept that databases have a unique key, such as Ben, Amy, and Cam, and then they have associated values associated with those keys. The matching algorithm applies to data, and one way to picture why it's important and why it applies so readily is to cast everything in terms of thinking about databases. So consider the two tables. Perhaps you have some expert in ages and you have some other expert in languages, and they've gone away and they've separately collected information on Ben, Amy, and Cam. And they've constructed their own tables, their own databases. And the goal here would be to merge, to synthesize these tables so all of the information is present for every key. But there's a problem. Nobody told the database compilers that they had to do it in a certain order. So they've just written down what they found. And you can see in the table on the left, Ben, Amy, and Cam are in a different order to on the table, how they are on the table on the right. And so what we need to be able to do is match Amy to Amy and Ben to Ben and Cam to Cam. Otherwise, the values associated with the keys will be wrong. If you just read off the first line and you assumed it was always Amy, you'd think that Amy was 28. And then you read the second line, you think Ben was 37, and that's wrong. You need to be able to match the keys so that the values are associated with the correct people, with the correct keys. Notice that matching something like Amy to Amy, Ben to Ben, it's easy to do by eye. It's less difficult to do in a computer. And for this reason, databases, the keys are usually integers. Not always, but most of the time. And even if you're looking at a table of information that's been compiled in a computer, and you think that you're sorting something alphabetically, or you think that the keys you're looking at are based on words, there's a very, very good chance that actually under the hood, the underlying key is actually an integer. So let's reimagine the exact same problem, but I'm going to change Amy into the number 1, Ben the number 2, and Cam the number 3. So now it should be a bit easier to see that the problem reduces to you have a couple of lists of numbers, 2, 1, 3, and 1, 2, 3, and you're going to have to try and match those. This is going to tie back very strongly to the sorting algorithm that we discussed 2 days ago. So if this problem seems difficult, just think of it in terms of having to sort these numbers, 1, 2, 3, so that they're all in the same order. Because once you've done that, once the keys have lined up, then it's easy just because the values are always going to be associated with the keys. It's easy to just tie the values together. The trick is getting the keys to be lined up in rows. So let's expand the problem a little bit. Instead of just Amy, Ben, and Cam, 1, 2, and 3, let's say we have 10 people, and in our database, we've turned those people's names into keys, and we've associated those keys with the numbers 1 to 10. And we've got some very boring information about these people. They're just letters, A, B, C, D, E, F, whatever. But focus again, the important thing is to focus on the keys. So, one person's gone out and collected information in database 1, the other person in database 2, and we have these keys 27935810146, and unfortunately the information was collected in a different way for database 2, 4816710923. So the goal here is to construct an algorithm that matches the keys in database 1 to database 2, and that is going to be your task for today. If this seems really difficult, if you're like, I don't know how to draw an arrow on the screen from 8 to 8, remember what we did 2 days ago with the sorting problem and realize that if the keys are sorted in order for both of the databases, then they're automatically going to match up. 1 is going to match 1, 2 is going to match 2, 3 is going to match 3. So this again is just an extension of the sort of sorting problem that I've made somewhat of a focus in this week's sessions. So your task for today is to write an algorithm, as we've been doing in the past, down in words. So I would do this, then I would do this, then I would do this, to try and match these database keys. And again, focus strongly on the sorting problem we've already done. As before, once you've conceptualized the steps you would go through to sort those keys so that they would be matched for two databases, write down your idea, your recipe, your algorithm using certain words. And these words I've changed from 2 days ago because now you've seen how I'm going to display things on a microbit a few times. I think it's better to use the language that the microbit uses, which is slightly more complicated than the language we were using 2 days ago, but pretty much equivalent. So you want to write looping through a list, trips down, you've got to touch each number once. I didn't write it explicitly like I did for the sorting algorithm, but again, base this strongly on the sorting algorithm from 2 days ago. Write the trips as for element number of list. Write comparisons. Again, you can have one empty box per list. Write comparisons if number less than, greater than the box. And write numbers, assign new numbers to a variable using the language set box to number. And append a new item to the list as new list, add value box to end. If this is a surprise to you, go back and review the material from sorting again from 2 days ago. As well as trying to use this language, just in general, write down your full idea. Once you have a recipe, an algorithm for matching the keys in the two databases, share it with somebody else, with someone else in the room or over Zoom, and see if they agree that the steps of your recipe would indeed sort the two sets of database keys in order so they would be matched up. In fact, it may even be easiest to directly try this in a microbit today using the microbit site. I've shared with the group my solution for the sorting algorithm from 2 days ago. All of my microbit solutions are available. So you could go to the microbit site and upload the solution and actually try yourself to turn the one sorting algorithm into two sorting algorithms to show that you're going to match up the ones with the ones, the twos with the twos, the threes with the threes. It's just a little bit of modification to what I displayed to you a couple of days ago.